If someone asks, how do you get there? What do you say? Do you tell them about the packed train compartment? Or how you have to leave when they want you to leave? Do you tell them you got there 2 hours early just to sit and wait? Or about the excessive amounts of pollution, the endless queues, the accidents, congestion, overcrowding, inefficiency, how antiquated it all is? We're Hyperloop One, and we're going to change this.
All right, so that kind of sets the stage here and gives you some background on the transportation problem that we have today. Increasing amount of population, it's expanding beyond the capacity of our transportation systems as much as we're trying to keep up with them, and increased urban densities and things of this nature. So all this congestion and inefficiency ultimately results in wasted time, wasted resources, and this is the area that we're targeting. So our vision is to reinvent transportation, to eliminate the barriers of distance and time. And it's a bold vision to move people and goods at very high velocities, kind of a packetized form that is more specific to where you want to be and when you want to be there. So how do we accomplish this? A little background here on the Hyperloop system. So you start with a pod that can carry either passengers or cargo. You put that inside a very low pressure vacuum structure or tube, and that eliminates drag and results in a very high energy efficient system that is propelled through an electromagnetic system. This is a linear electric motor that we've custom designed in-house, and all this is suspended from a magnetic levitation system. Again, a low drag, low wear, low maintenance system. And wrap all this together in an autonomous control platform. So there's completely driverless, all autonomously controlled, and resulting ultimately in safer system that can operate at these high velocities.
Imagine traveling non-stop at up to 670 miles per hour, above land or underground. This is Hyperloop, a new mode of transportation that has been developed by Hyperloop One. It starts with an electric motor, which is broken up into two basic components: the rotor, which rotates, and the stator, which is stationary. The stator is an electromagnet, so when an electric current passes through it, the rotor is magnetically attracted to spin. Unlike a normal electric motor, the Hyperloop One motor isn't circular, it's linear. And the rotor is on the pod, which is propelled magnetically as it moves over the stator. Hyperloop One's unique technology uses magnetic levitation to guide and lift the pod off the track. Nearly all of the air inside the Hyperloop tube is removed using a series of vacuum pumps. This effectively creates our own sky inside the tube, as if you were quietly flying at 200,000 feet above sea level. This reduces drag so only the smallest amount of electricity is needed to achieve extraordinary speeds and creates a more cost and energy-efficient system than high-speed rail or airline transport. Hyperloop One will be automated by the most advanced systems in the world, allowing a safe and efficient journey that's never delayed or overbooked. Hyperloop is the first new form of public transportation in over 100 years. Fundamentally, it will change the way we travel, work, and live. Welcome to the future. Welcome to Hyperloop One.
All right, so how to get all this information out there first, kind of answer any questions that people often have about the technology and how it works. So we can get a little bit more details into some of the specifics of the impact to the broader economic and social benefits. So this technology that I've just described here, this enables us to travel at 300 meters per second, over 1,000 kilometers per hour. And this is airline speed with the kind of the convenience of a metro, if you will. So this allows you to travel from London to Manchester in which is over 300 kilometers in just 20 minutes on a Hyperloop system. Similarly, if you were to travel this on high-speed rail, it'd be an hour, conventional rail, 2 hours. A road truck would be over 4 hours. So we're really kind of having a total paradigm shift here in what you can access within a typical 30-minute commute time. And just a few other examples of common city pairs, especially some that we're looking at in a lot of detail right now around the globe, and what those time of travel would be between them. So I mentioned briefly packetized transport. So this idea is, rather than a very long train full of hundreds of people, you can send a smaller vehicle more frequently. Because it's low energy, you can send these smaller vehicles more frequently. And that allows you to have this point-to-point destination. So rather than one large linear connection, we can connect to a number of other areas of interest around the city, whether it's commuter zones or regional centers, ports, airports. And now you're no longer having to stop at each station along the way. You get in your vehicle when you want to, and you get to your destination without stopping at everyone else's destination. And this all ties into some of the existing modes of transportation that we have. So we're not replacing these other systems, we're adding to them. Along the autonomous aspect that I mentioned, so this will include a huge suite of sensor data, environmental controls to keep passengers comfortable inside the vehicle, localization, so we always know where the status of the vehicle, where it is, health monitoring. This is all tied into a huge diagnostic center, kind of an aircraft control center, if you will, that allows us to know where all the vehicles are at any given point, and auto detection and braking, of course, for safety. So with that large command center, we're able to have real-time traffic scheduling, so dynamically know when there's going to be an increase in travel at commute times after a big sporting event, and interoperability with last mile providers. So this is your Ubers and Lyfts of the world, autonomous vehicles that can then let our system know when you're arriving at the station and when you are departing that station. So an example of how this could work here is this is all built into an app. So if you decide you want to have a special dinner and you're in the Netherlands and want to go to Berlin, this is a possibility. 5 o'clock rolls around, you pull out your phone, you select your destination. It is all automated through this payment. Security is done on the back end here. It arranges for your autonomous vehicle to pick you up, take you to the station. Portal is the term we like to use. You get to the portal knows you're arriving in your autonomous vehicle, so your pod is there waiting, ready for you. When your pod arrives on the other end, it's also tied into your vehicle, autonomously driven vehicle that you then takes you to the final destination. All right, so now you're getting a good idea of how all this works, how the user would end up being involved with this system. And I'd like to touch on a little bit on how this reinventing transportation has a huge impact on social, economic, and environmental aspects. So if you look at industrial revolutions, and like there's been many eras that have been defined by a new mode of transportation. So from trains in the Industrial Revolution to automobiles and personal mobility and city expansion, airplanes with global connections and commerce, and now with Hyperloop in the 2020s for hyper-connected mega regions. And it's been over 100 years since the last mode of transportation, so we believe it's time for a new one here. And what we can accomplish is to effectively turn nearby cities into metro stops. So you expand from what is typically a 30-minute radius inside a metro system contained within a city to a 30-minute radius that spans across multiple large cities. And this acts kind of like a new broadband for actual physical people and things. And this connectivity adds to sharing of knowledge, labor, and investments, which can result in regional vitality and increasing virtual density, and create new business innovation hubs, job growth, productivity, and improved access to talent. So we're not selling transportation here, we're selling time. And that is, again, this 30-minute radius increased hugely, which means that you have access to higher wages in a neighboring city, that you can live in a lower cost area, and more access to connecting other infrastructures, whether it's airports, big hubs. And our system is very energy efficient. So this is all electric and low drag because of the low pressure environment inside the tube. So through this, moving vehicles, people, trucks off of roads, we can reduce congestion, have more efficient land use. You saw some of the images that showed an elevated tube structure. So we have reduced impact to a footprint of the land below us. And sustainable operations. Again, all electric can be powered from a number of renewable energy sources. This shows an example here of the Hyperloop system in the lower right of where our energy efficiency is compared to a lot of other systems. And a lot of the comparisons here are not chosen to make us look great. We have a number of other pretty energy efficient solutions: electric vehicles, electric trains, electric buses. But the big aspect is traveling at very high velocity. Typically that requires much more energy because of the drag going with your energy, with your velocity squared. So in our case, we're able to maintain this low energy use even at high velocities. So the real impact here is when we start talking about networks, big networks, and that's where there's a huge multiplicative factor for Hyperloop. So this can be done in the US, in a European network, in the Gulf, and these are all areas that we're actively engaged with for furthering some studies with local governments and other entities. Further aspect of the Hyperloop system is to enable a whole new supply chain and impacting efficient manufacturing and distribution processes. So this can change the way we use ports, the way we have inventory management. In case of manufacturing, this is something that could enable just-in-time, agile manufacturing. You can move things immediately when you need them. Along those lines, with distribution, on-demand delivery takes now hours instead of days. And ports, expand port capacity, move ports inland, reclaim some of this very valuable and high natural resource of coastal land. And ultimately, this moves things outside of the urban center, resulting in a less congested and more pleasant place to live. So a lot of this has been graphics and videos, but I'd like to point out a little bit here on what we've accomplished as a company with Hyperloop One and kind of show you where we're at today. So far, we've had a lot of innovations and focus from the engineering team on low-cost tube structures, our custom-designed linear electric motor, the magnetic levitation system, and control and safety, especially through this autonomous feature that I've mentioned. And we've been focusing on a lot of the key tenets that I've described that we want our product to be, which includes direct, on-demand, high capacity. We're talking initially 10,000 passengers per hour for a given route, and this can increase to about double that, and comfortable. So in the video, the gentleman's enjoying his coffee, sitting, reading a paper. So even though we're traveling high velocity, it'd be similar to taking off an airplane off a runway. Similar acceleration loads, and in that case, you're traveling at high speeds in a comfortable environment. A few more points I've already mentioned, so I'll breeze through these in the interest of time. And we've had a lot of interest. So we already have a number of projects underway around the globe. One that's probably the farthest along is in Dubai with the RTA, the Road and Transport Authority. And we have a number of others as shown here. So a number of initial studies at varying levels from a pre-feasibility to a feasibility study and getting into some more detailed design. We've also had a Hyperloop One global challenge that we opened up to anyone around the world and had a bunch of submissions, hundreds of registrants. People submitted a lot of proposals, 60 plus, from 25 different countries. We've now selected that down to about 10 or dozen finalists, and those are captured actually in a few of those are in the previous slide. So some of the use cases that we have with Hyperloop vary in terms of people or freight and from the distance. So somewhere between 50 kilometers to 1,000 kilometers, kind of our sweet spot. And you can see here in the case of the top left is kind of where we're starting with people in Dubai. So this was a connector similar to a metro connector. It could be an airport type connector that's around 50 kilometers in length. And then we expand these to larger regional networks, intercity, regional, and even international networks. So in the case of Dubai to Abu Dhabi, ultimately this is something that could take 12 minutes, start at one end, the north end in the Dubai airport, and end up down at the Abu Dhabi International Airport in 12 minutes, which normally takes about an hour and a half in a vehicle, which is also can take longer with traffic, of course, and then you have people traveling at very high speeds that is also unsafe, so there's a lot of benefits to our type of system in this case. So as a company, Hyperloop One, we're the only one that's currently actively building this technology. So I know there's a nice fancy PowerPoint to support this as well, but we're also have built a test track in Las Vegas. There were some images of that as shown also. So we are very focused on building things at scale and building innovative new technologies with a lot of new proprietary key systems that we've developed. So some of our talent, we now have a team of over 300 people, and they've come from a number of great companies and universities all over the world. This picture is actually very outdated. It's over a year old, so we have quite a few people beyond that. But we're based in Los Angeles. We have our innovation campus there. This is where we do the core engineering. The bulk of our company is located here. We have a few test rigs that we've built, custom designed and built just because of what we're doing. It hasn't been done before, so we have to actually design, build test rigs just so we can design and test our new technology. So this is, in this case, is showing a levitation test rig. This is something that we designed, custom built, and still using today. We've been using it for 2 years. We also have the world's first Hyperloop factory in Las Vegas. This is in North Las Vegas near our test site. And that test site is where we've conducted both initially a propulsion test. So this is testing our linear electric motor in May of 2016. And this, we accelerated a sled to 134 miles per hour in just over 2 seconds. We then expanded that into a full system dev loop test. So this is world's first full-scale Hyperloop test. It includes the vacuum structure, includes the linear electric motor, magnetic levitation, autonomous controls. And we built this over the course of a little less than a year. And in May, had our first, what we call Kitty Hawk moment, in reference to the Wright brothers at Kitty Hawk in North Carolina, where they had the first airplane flight. So in this case, this was the first full Hyperloop system test with achieving magnetic levitation over 100 feet and at 70 miles per hour. And from that, well, first I'll point out a few things why we call it this Kitty Hawk comparison. So similar to lifting surfaces, we have levitation bogies that provide lift. And similar to the canards and wing warping and rudder that you'd have on an aircraft, we have guidance along our vehicle as well. And the propulsion system, the linear electric motor, the stator and rotors that I've mentioned as well. So from that chassis, we then expanded to a full pressure vessel here, aeroshell, and placed that on the aeroshell and had a full speed test getting up to over 300 kilometers per hour. And this was completed in the end of July. And from that point, we have ongoing testing, increasing speeds, and continuing to develop towards production system. So a lot of engineering accomplishments to date. This highlights a few of them. So we start with very early on in 2015, 2 years ago, with a large vacuum structure test so we could get comfortable with operating in this low pressure environment. A couple of the custom test rigs that I mentioned are shown here. Blade Runner, which is a wind tunnel test. Again, we had to design and create our own test rig just to test in this unique environment because of the high velocities and low pressures. Levitation rig, and so forth. So now we're on to the bottom right there, where we're starting to get into production development. And this is where we now take what we've learned from DevLoop and apply that to something that is scalable and can be built over a large distances. So next video will kind of take you from our vision from where we're at now into what's next.
All right, all parties ready for tests? Firing in 5, 4, 3, 2, 1. Fire.